Okay guys, let's have a look at this series then. It's 1 plus a half plus a quarter plus ... plus 1 over 32. Now we can think about this in a couple of ways actually. If you look at this sequence underneath, you could write the 4 as 2 times 2, couldn't you? So you could start to write down the sequence in that manner, couldn't you? And that would be one possible solution. The other way you could look at it, if you look at this, you see it's a half. If you times a half by a half, you get a quarter. And you times 1 by a half. So the other way you can look at it is you're timesing succeeding terms or subsequent terms by a half. So a half times a preceding term will give you a quarter, and then you go along. So how many halves? 4. It would be 8, 16, 32, wouldn't it? Up to 32. So there's not many terms to write out here. The only problem area is this one. But let's just proceed and try and generate the pattern here and see how we can modify the 1 and write it in a different form. Still keep it as 1, but write it in a different form so that it appears like it can be written as part of a pattern. So the first one was a half, wasn't it? So I'll put that in a bracket. The quarter can be written as a half times a half. And then we just carry on doing the same thing because we're timesing each subsequent term, timesing a half of the preceding term to get the subsequent term, yeah? So this would be cubed, that would give us an 8th. A half to the 4 would give us a 16, and a half to the 5 would give us that 32. So there's our last term, and that was power 1, isn't it? We don't usually write it, but we'll put it in explicitly. Now, anything to the power 0 is 1. So the good thing is here is I can just write that half as half to the 0. Yeah, and that's what we've got. So that's nice, everything's in the same form, but everything else bar the counting digit is in the same form or pattern. It's the halves to this power, isn't it? That's a counting digit. So the first one would be a half to the r. Let's just double check it. This is half to the r, isn't it? This is half to the r, agreed? And this can be written as half to the r. And similarly the last two terms in the sequence. So we've got r as 0 here for the first one. That gave us 1, then 1, then 2. I know I'm writing out long-windedly, but it doesn't take a moment or two to do. And then we can avoid making mistakes, and everything is kosher. So we've got the sum of half to the power r from r equals 0 to 5. 6 terms in the sequence then. And there's a sigma notation. Now you'll notice that I mentioned that at the outset that we could have just looked at the bottom denominator and noticed it was timesing by 2 each time. And here you can manipulate this, because if you wanted to, you could write this as equal to the sum of r equals 0 to the 5. A half to the r is just, you use the power rule, so that will be the top number to the power r, 1 to the r. Right, 1 to the r, which is just 1, because 120 power is 1, over 2 to the r. So you can just simplify it like that, using properties of indices. So we could have done that from the outset and got this form. We just decided to look at it in this way and get this alternative form. Both would be marked correct. So good, that's question 5 done. Great.